My name is Jocelyn Tapia from the Universidad Católica del Norte in Chile, and this study is entitled Distribution and Potential Mobilization of Arsenic, Copper and Zinc in the Camarones River Basin, Surire Salt Flat, and Caritaya Dam, northern Chile. This assessment is part of a project funded by the National Agency of Research and Development of Chile, also referred to as ANID, which aims to identify natural and anthropogenic geochemical anomalies in contrasting areas of Chile. These results are focused on northern Chile, an area that still has no guidelines for potential inorganic contaminants in soil or sediment, despite the presence of natural elevated concentrations of elements as arsenic and copper, as well as the chronic exposure of some of its inhabitants to arsenic. The study area is located in northern Chile, extending from the Chilean coast to the Andes Mountains, and it includes the Altiplano Puna Plateau. The Camarones River Basin extends approximately 110 kilometers from east to west. To the east, it is connected to the Caritaya Dam, whose waters are highly influenced by the Amullo Ponds, located to the southeast of the dam. 30 kilometers to the northeast of these ponds is the Surire Salt Flat, which contains the Polloquere hot springs in its southern area. The Camarones Basin, Surire Salt Flat, and Caritaya Dam are located at elevations ranging from the sea level to 4,250 meters above sea level. The climate and precipitation varies in the west-east direction from less than 20 millimeters per year to more than 200 millimeters per year in high elevation areas. Precipitation usually occurs in the austral summer, which is between December and May. In addition, these basins are known to have low population density and limited anthropogenic activities that include boron mining at the Surire Salt Flat, small copper operations on the coast, and agriculture in the Camarones River Valley. During March and July of 2019, 2 sampling campaigns were performed in the Camarones River, Surire Salt Flat, and Caritaya Dam. The sites were selected to identify the main trace elements present in this area and their potential for mobilization in contrasting seasons. Due to their concentration in water or sediments, arsenic, copper, and zinc were selected. Water samples were filtered using a 0.22 micrometer syringe and were acidified using nitric acid in the field. Water samples were analyzed by ICP-MS at the Analytical and Environmental Chemistry Laboratory of the Pontifical Catholic University of Valparaiso in central Chile. Sediment samples were retrieved from the upper 5 centimeters of 1 square meter surface area. In the laboratory, sediments were oven-dried at 50 degrees Celsius and sieved. The fraction, lower than 63 micrometers, was digested using 300 milligrams of the sample, 4 ml of chlorhydric acid, and 12 ml of nitric acid in hot plates. The digested residue was quantified by an optical emission spectrometer at Sasa laboratory of the Universidad Católica del Norte. The clay and silt-sized particles, or sediment fraction lower than 63 micrometers, were subjected to a sequential digestion following the methodology of Tessier et al. From 1979. This procedure was performed to identify if arsenic, copper, or zinc correspond to potentially mobile elements within these sediments. The digestion used to obtain fraction 1 is the lightest, representing the more labile elements, while fraction 2 is intended to release elements associated with carbonates. Fraction 3 is related to amorphous oxides, while fraction 4 is associated with organic matter or poorly crystalline sulfides. Finally, fraction 5 is considered to represent a low mobilization potential. During summer, 8 samples were taken at the Camarones River, 2 in the Surire Salt Flat, and 2 at the Bitter Creek. In winter, 8 sampling points were collected at the Camarones River, 3 at the Caritaya Dam, 2 at the Surire Salt Flat and 1 at the Poyoquere Hot Springs. Physicochemical properties of water were characterized in the field. In general, water samples were oxidizing and slightly alkaline at Camarones, Caritaya, and Surire. Nevertheless, at Poyoquere, waters were reducing and presented a lower pH. The highest concentration of dissolved arsenic and zinc were found at Caritaya Dam, and the lowest values were found at the Poyoquere Hot Springs. The concentration of copper was below the detection limit for all studied sites. When comparing winter and summer, there were no important differences in the concentration of arsenic. However, zinc concentrations were higher in the summer. Regarding sediment concentrations, the highest values of copper are found at the Surire Salt Flat and Caritaya Dam. The highest values for particulates arsenic are found at the Poyoquere Hot Springs, and the highest values of zinc are found at the Caritaya Dam and Camarones River, as represented by the size of the circles in the plot. Regarding the seasonal differences in sediment concentrations during summer and winter, average arsenic values tend to increase in the winter. The same pattern is observed for copper in that its average concentration increases during winter. On the contrary, mean concentrations for zinc remain similar between summer and winter. The potential of mobilization for arsenic was higher in winter for the Camarones River Basin. Nevertheless, at Surire Salt Flat it was higher in summer, especially when related to organic matter or poorly crystalline sulfides. At Camarones River and Surire Salt Flat, the partitioning of copper is quite similar between summer and winter, although the total concentration is higher in winter and copper tends to be related to carbonates in this season. At Camarones River Basin, zinc presents very similar partitioning during summer and winter, while at the Surire Salt Flat the concentration and partitioning of zinc increases in winter. The previously shown results indicate that this part of Chile has elevated concentrations of arsenic in water and sediments. In the case of water, all arsenic concentrations are well above national and international regulations. In the case of sediments, Chile does not have guidelines, and when comparing the average value of arsenic in the different studied basins to the Canadian Sediment Quality Guidelines for the Protection of Aquatic Life, most of the studies present concentrations well above the probable effect levels. The concentrations of copper and zinc in water are well below national and international guidelines. In sediments, zinc presents values below international guidelines, whereas copper is slightly enriched in these sediments when compared to recommendations for freshwater systems such as the Canadian guideline. The richness of arsenic in northern Chile has been identified in previous studies. It is believed that elevated arsenic concentrations are related to the volcanic outcrops of the central volcanic zone, coupled with a thick crust, regional structural systems, and geothermal fields. All of these characteristics are found in the studied zones. In addition, current research has shown that the Amuyo ponds are a source of arsenic for the Caritaya Dam and consequently for the Camarones River, which is a fertile valley in its lower reaches. The slight enrichment of copper in sediments is likely related to geological factors, as Chile is one of the most important producers of this metal in the world, and small copper mines are present near the coastal areas. Another important factor of northern Chile is its climate. No important differences of arsenic concentration were found between winter and summer in the Camarones Basin, yet zinc concentrations were higher in summer. This might be explained by intense precipitation that affects this area during the austral summer, known as altiplanic winter. On the contrary, the studied elements in sediments presented higher concentrations during winter, as well as an increased potential of mobilization. This might be explained by the fact that during this season precipitation decreases and there is still an important amount of evaporation, which can precipitate these elements. The most important anthropogenic activities of these basins correspond to mining and agriculture. There were no identified anomalies in the studied elements in relation to these activities, although it's noted that the Camarones River Valley is fertile. Attention should be paid to the water used for irrigation purposes and if the vegetables produced are free of arsenic. The main conclusions of this study include that in the studied basins, water is enriched with arsenic. Its concentration remains similar in different seasons, whereas zinc increases in winter and copper is below detection limit in both seasons. Sediments show an increase in concentration and potential of mobilization of the studied elements in winter, which might be related to precipitation from the water column. No important influence of anthropogenic activities was found for arsenic, copper, or zinc. As main recommendations, we include the following. Guidelines for inorganic contaminants in sediments are necessary for the Chilean regions. The importance of microbiological activity should be addressed, especially for arsenic, and it is important to identify arsenic-bearing minerals. This study would not have been possible without the valuable help provided by students, laboratory staff, researchers, and drivers that helped to obtain and analyze water and sediment samples from the Camarones River Basin, Surire Salt Flat, and Caritaya Dam.